So in example 1, we're looking at the syllogistic argument. All trees are plants. All plants need water. Conclusion, therefore all trees need water. For a syllogistic argument, we draw an Euler diagram. We start with the first statement, all trees are plants. And that means in the circle of trees, so if we imagine we have all the tree names here in this circle for trees, then all of them are plants. So it's a bigger, wider circle that holds all the plants. And now notice anything that's a tree will also automatically be a plant. So this is the diagram for all trees are plants. Now all the plants need water. So all of these plants need to be into a big circle for everything that needs water. There are other things that need water, but the plants are definitely in that circle. Now we look at that diagram and see about all trees need water. Is it true that the entire tree circle must be inside the entire needs water circle? Yes. If I had the tree circle outside at least partially of the needs water circle, then it could not be completely in the plant circle. So this diagram is proof that this is a valid argument. So when we do all, we're looking to have one circle inside the next circle. So all the trees need to be inside the plant circle, etc. Example 2, determine the validity of the argument. All teachers grade exams. Kelly is a teacher, therefore Kelly grades exams. Because we have the first statement, all teachers grade exam, here are all the teachers in this circle for teacher, and all of them are inside a larger circle of people that grade exams. So now all the teachers grade exams. Kelly is one particular teacher. When you have a 1, you don't use a circle, you use an X or a dot. I like an X, but you can use a dot, it doesn't matter. So Kelly is one teacher, so she's one particular item in here. And maybe I'll even make a little K so I remember that's Kelly. So Kelly is inside the group of teachers. So this is true now. Does therefore Kelly grade exams? Yes, Kelly's inside that teacher circle, so she must also be in the grade exam circle. So this is a valid argument. And the proof is this Euler diagram. So you're going to include that Euler diagram whenever you determine the validity in order to get full credit. Next, determine the validity of the argument. All soccer players are athletic. Casey is athletic. Therefore, Casey is a soccer player. Let's see what the diagram looks like. We have all the soccer players. So here's the circle for soccer. And all soccer players are inside the circle of people that are athletic. Okay. That is the first statement. The second, Casey is athletic. Now, Casey could be here outside this athletic circle, or Casey could be in here inside the soccer circle. There's two possible places she could fit in, inside the athletic and outside of soccer, or in both. So we have two different possibilities for Casey. Sometimes people like to call them Casey 1, Casey 2. It doesn't matter that much. I'm just going to point out that there's two possibilities. Now let's see if our conclusion is therefore valid. Therefore, Casey is a soccer player. Well, we see in this example that Casey could be a soccer player, or Casey could not be a soccer player here if C2 is actually the one that's true. And we don't know whether it's C1 or C2 that's true. So therefore, this is invalid. Anytime there's a possibility that this is invalid, then you have to say it's an invalid argument. Remember, it's when we were doing the syllogisms in Unit 1, we said we just had to find one example where something wasn't true. So as long as we say Casey might not be a soccer player, then the argument is invalid.